Hey guys, this is a big one today. We are going to talk about comparing and ordering numbers, and this is going to be hugely important for the whole of eighth grade. Now, if you're in Virginia, you probably did a version of this before in sixth or seventh grade, but in eighth grade, it just gets a little bit tougher. We can give you up to five numbers, and the questions just get a little bit harder. So, we're going to start with a review of some symbols, and then we'll get into the nitty gritty of it. So, right here on the screen, we've got a review of inequality symbols. All right. So over here on the left, we have what less than looks like. And over here on the right, we have what greater than looks like. And if you have a hard time remembering this, a number line can be really helpful. So on the left side of the number line, there is a less than symbol. See how that matches this? And that's because the numbers over there are smaller. Versus on the right side of the number line, see this symbol here? That means greater than, and we can remember that because the numbers on that side of a number line are greater than. So 0 would be somewhere in the middle, and then -1, -2, -3, this would be -4. 1, 2, 3, 4. -4 is less than, and +4 is greater than. So that could maybe help you remember if you have a hard time remembering less than and greater than. So we're going to start with what I'm going to call some baby problems. We've got pictures, right? So this says use inequality symbols to compare the quantities. And I have 4 stars and I have 3 stars, and we're just going to practice using those symbols. So I know that 4 is greater than 3. So I'm going to use a greater than symbol to compare those images. And this is just a refresher. This is not what the 8th grade math is going to look like. This is just a refresher. And then the next one, I have 2 suns and I have 4 suns, and I know that 2 is less than 4. So I'm going to use a less than symbol. All right. Let's compare some actual numbers. Now, the Benson-Voss method for this might be different than how you do it or how you've learned to do it at your school, but this is how we do it in our classroom. And if your teacher wants you to do it a different way, 100% listen to them and use their method. A lot of teachers and a lot of schools tell you to convert all of your numbers into decimals and then compare or order. We do something a little bit different. We use percentages. So we're going to turn each of these 4 numbers into a percent and then use the less than and greater than symbols to compare them. So I'm just going to go through each one and see what we've got. In the first one, I have 250%. That's already a percent, and since in the Benson-Voss method we're changing to percents, I'm not going to do anything to that one. But I'm going to go over here to the next number, 0.345, or 345 thousandths, and I'm going to have to change that to a percent. And the easiest way to do that is to type in your number in Desmos and multiply it by 100. In fact, let me come up here and write multiply by 100 so that we don't forget. Okay, and then that is now a percent, 34.5%. And I can compare these really easily. It's very difficult to try to compare percents, decimals, fractions, scientific notation, square roots, all these different things until they're the same form, which is why we change everything to a percent. It makes it super easy to compare. So we have 250% and 34.5%. And I know that 250 is greater, So I'm going to put a greater than symbol. Then I'm going to go to my next one and I'm going to do it the same way. This time I notice that neither of my numbers are percents. So in Desmos, I'm going to change them both into percents by multiplying both of those numbers by 100. And then all of a sudden, this problem that looked crazy and kooky and difficult becomes much simpler. So 1/5 is the same as 20%, and 1.7 times 10 to the negative first power is the same as 17%. And then I can say, oh, 20% is greater than 17%, and I can put my symbol there. So that's really why we convert everything to a percent, to make it as simple as possible. But if your school and your teacher wants you to convert to decimals, that's fine. Just make sure you double check with them and you're doing these right. Okay. Now, here comes the meat and bones of this, or meat and potatoes, or whatever the expression is. I don't know it. In 8th grade, a lot of the times when you see a question like this, whether it's in class, on a test, on an SOL, whatever it could be, you're given a lot of numbers, 4 or 5 of them, and you need to put them in order, whether that's on a number line, in a list, something. So that's what we're going to practice. We're going to do 2 of these, and they're going to take a few minutes each, but really pay attention and make sure you understand every single step. Okay, and again, I'm going to be using the Benson-Voss method, where we change everything to a percent. If you need to do it differently for your school or your teacher, go right ahead. So our directions say convert each number to a percent. And I know that I do that by multiplying by 100, but I'm going to go ahead and write it one more time, because the more you write things, the more likely your brain is to remember it. Okay, and then I'm going to come over here to Desmos and I'm just going to start putting in these numbers. So I have 2/5 times 100, 5 times 10 to the negative first power times 100, the square root of 5 times 100, but make sure the times 100 is outside of the radical sign, not underneath. And then 55% is already a percent. So I'm just going to put it in there because I don't want to forget about it and forget to order it, but I don't need to do anything to it. If it makes you happy, you can put 55% of 100 if that sort of makes your brain happy, because then all of them look similar. And then I'm going to come over here and I'm going to rewrite all of these as percents. This isn't something you necessarily need to do like while you're taking a test, but I'm going to do it right here for your sake. So 40%, 50%. The only thing here is if you're going to write it all out again, you do have to be really careful you're writing everything accurately. But I know in our class, we don't mind if you use Desmos as your scratch paper. So there's my 4%, and then I'm going to put them in order. This says ascending. And if you remember, ascending means we are going up. We are starting with the least, and we are going up to the greatest. So I'm going to look at these 4% and I'm looking for the least value. And the least value is going to be that 40%, but I'm not going to write 40% on the line. I'm going to write it in the original form, which is 2/5. And then if you're using Desmos as your scratch paper, what I like to do is just delete that line really carefully, make sure nothing else disappears. But now that number is gone. I'm not going to cross anything off on my notes because I don't want to make them messy. I'm just going to move on to the next number. So now, of the 3 numbers I have left, which one is the least? And I can see that the 50 is the least. So I'm going to write that one next. 5 times 10 to the negative first. Now I only have 2% left, 223.6%, 55%. Which one of those is least? The 55%, which means the square root of 5 is the greatest of those four numbers. Now, if you need to go back and watch that one again, do it. I think go back to like the 7-minute mark or the 6.5-minute mark of this video and watch this example again. I'm going to move on to the next, but make sure you've got this before you do that. So our next example has some different types of numbers in it. I've got a mixed number. I've got another scientific notation. I've got a number with pi in it. I've got a negative decimal. So the first thing I'm going to do is I'm going to convert each of these into a percent. And I have to do this first one a little bit funny because I actually don't have a keyboard right now, but 1 1/3 times 100, 3.1 times 10 to the negative second power times 100, 2 pi times 100, and negative 2.5 times 100. None of them were percents to begin with, so I have to change them all to percents. So I'm going to write these down on the notes page. I've got 133.3%, 3.1%, 628.3%, and negative 250%. And this time my question says, write the numbers in descending order, which means I am going down, starting with my greatest and going down to the number with the least value. So I'm going to look at these 4%, and I'll use Desmos again as my scratch paper. And I'm going to say which of these 4% is the greatest. 133%, 3%, 628%, or negative 250%. And I think we can all agree that 628 is the largest, meaning I'm going to write 2 pi first. And then I'm going to clear just that line out of Desmos. Then I'm going to look at the 3 that I have left and decide which one is the greatest. And this time it's 133%, which was originally 1 1/3. So I'm going to write that next and then clear it. Then I'm only down to 2. I have 3.1%, which is small, but my other number is negative 250%, and negatives are smaller than positives. So the next greatest is 3.1%, or 3.1 times 10 to the negative second power, making my smallest value the negative 2.5. All right, if you need to rewatch either of those examples, please do. I know they took about 3 minutes each to get through, but make sure you've really got those down before you go on to any other videos. Great job.